Okay, so this is going on page 59. And we're going to title this Graphing Rationals. Oh, good Lord. Directly in your ISN, like I said, page 59. Good Lord. We got distracted by heels. Okay, so I'm going to give you, we're just going to do one example, and I'll tell you when to stick the little graph on there, so don't get ahead of me on that. So I'm going to give you f of x equals 2x squared plus 3x minus 9 over x squared plus 3. So for rationals, the first thing we do is what? Factor. So go ahead and get this thing factored. Yeah, we're going to do all the pieces. It's just not all right now. Yeah. Okay. We'll see how that works out. So do y'all agree with my numerator? Yes. Can you factor the denominator? No. So it has to stay x squared plus 3. I mean, if you can't, you can factor out a 1, that doesn't do you any good, right? The only time factoring out a 1 is going to do you any good is when you're factoring by grouping, but other than that, it's not doing any good. Okay, so then when we want to go to graph this, now, and I want you to think about these things without looking at your notes or an assignment that's next to you or anything else. When we did this, after we factored, what was the first thing we always looked for? Holes, okay? So that was your point discontinuity, right? And then after that, it's radii. So it's r a t squared e y. Because the whole idea of having something like an acronym like this is so that when you don't have all the blanks written out for you like I've had on everything, you could still find everything you need to get the job done. Okay. Or RAT 2E. Yeah, it'll have it written out in our quiz. All right, so are there any holes? Or is there any point discontinuity? No. Okay, so then again, without looking at anything else, what did the R stand for? Roots. Okay, so my roots are -3 and what? 3/2. Yeah, be careful with that. It's easy, but it's also easy to get it backwards. All right, so A stands for what? Asymptotes. Which ones? Vertical. Okay, do I have any vertical asymptotes here? Vertical asymptotes come from where? The denominator. They're the zeros of the denominator. So if I take x squared plus 3 and I set it equal to 0, oops, I'm going to get x squared equals -3. So when I take the square root of both sides, I'm going to get plus or minus the square root of I times the square root of 3. So it's going to be an imaginary number. Is that going to help me at all? No. Like it's imaginary, so that's not an asymptote. So what that means is I can't get any zeros down here, so there are none. Okay? No vertical asymptotes. You can't force it into there. If it's an imaginary asymptote, then it's just that. It's imaginary, and you can't grab it. Tangency and togetherness. Good. Do we have either one of those?
Yes. Togetherness on the denominator.
No. I know why you're thinking that, because you see the x squared, but here, that's another reason why we're doing this one. There is an x squared, but in order for it to have tangency or togetherness, the factor has to have an even exponent. So this isn't the factor. You with me on that? Uh-huh. Yes, because the factor then would be x. Yes, absolutely. Good. All right, so then that means this is none, right? E stands for what? No, not here. What did our E stand for? Or what were we finding when we got to the E? Asymptotes, because it's end behavior. So your end behavior, asymptotes. So your end behavior is your horizontal and your slant asymptotes, right? So do I have a horizontal asymptote here? Yes, I do, because they are tied in degree. So that means it's y equals what? 2, because the leading coefficients are 2 in the numerator and 1 in the denominator. Y stands for y-intercept, so I can get that from this right here, and that gives me 0, what? Negative 3. So now if you actually listed everything over to the side like this, then you should have room for your graph. Now don't stick it down just yet. If you don't have room for it right where I'm putting it, you should have room for it somewhere. But you're going to put it landscape, not portrait. Landscape, yes ma'am. As long as they are both multiplied out, yes. So her question was, does this always work for the y-intercept? As long as they're both fully multiplied out, like I wouldn't get to do that here. And then basically what you're doing is you're saying everything I substitute 0 in, everything with the variable is going to go away because they're all going to 0 out, and so you're only left with the constants. So yes. Okay, so make sure it's long ways, not portrait, and then you can go ahead and carefully place this on your paper.
And the way that you check and see if it crosses the axis.
Yes, we're still going to have to do that. We're still not ready to graph just yet, but I wanted to go ahead and get the graph on there so we actually had room for it, and then you can write stuff around it.
Wait, so not portrait, we're doing
Landscape. So it's wider than it is tall. All right, so all right, so before we even graph, like I said, I wanted to get it on there so that we could make this work. We're going to do our number line. How many things go on the number line? Yes. 2. The things that go on your number line are your roots and your vertical asymptotes. And I only have a roots. I don't have any vertical asymptotes. So I'm going to have a negative 3 and a 3/2. So then I test it. Well, I was rewriting the equation because I couldn't see it without scrolling on my board. So you can, but you don't really have to. I mean, you can just use this one. But if you can see it, fine. It's okay that you don't rewrite it. So I'm going to pick negative 4. When I do that and I substitute it in here, I'm going to get negative, negative. And then the denominator will give me positive every time. You agree with that? Okay. So that means this is positive overall. In between these two, I can find a 0. So when I substitute in 0, this is going to be negative, positive, and then positive in the denominator. And then 3/2, so I'll pick 2. When I substitute that in, I'll get positive, positive, positive. It's positive overall. So then when I shade positive, negative, positive. Well, kind of, but it's still not. Still not. All right. So now we're going to start looking at our graph. You're so brilliant. Okay. We are going to, if you don't have to count the boxes or anything, but just aim for the middle to get your Y and your X axis on there, middle-ish. You can use your straight edge. Your ID would make a great straight edge. Yeah, you could have folded it in half before we stuck it down, but then we'd have had... That's okay. I'm probably off by 1 square too. Like I said, you don't have to count.
Yours looks perfect.
Well, I have some experience. I'm kind of a big deal. Just kidding. All right. So funny. Alrighty. So now let's go graph some things that we can graph on here. I do not have any holes to graph. I have roots at negative 3 and at 3/2, so that's like 1.5. And then I don't have any vertical asymptotes. I have a horizontal asymptote at y equals 2. Looks like that, except I didn't quite get the axis, but you get the idea. Just make it wider, I guess. Whatever. This is why I should use pencil. I can't erase that. There's my weird asymptote. And then 0, negative 3. I know. It looks weird. Don't judge me. So now, here's what I know from this. From negative infinity to negative 3, it's positive the entire time. But I don't know if it stays underneath the asymptote, if it comes above the asymptote. I don't know. Then from negative 3 to 3/2, it's negative. So that makes sense. It's going to come down and hit that right there. Then it's going to come back up. Then from 3/2 to infinity, it's positive. But again, I don't know if it stays underneath the asymptote or if it's going to go above it. And I accidentally wrote on this twice, and I cannot erase that. So just ignore those forms. Okay, so I have to check to see if and when this is going to cross the asymptote. So when I'm doing this and I'm working it out, I think on all the examples yesterday, I probably rewrote this one and went with this because that's the one I could see. But you're going to have to multiply it back together anyway, so you might as well start with the multiplied version. So I'm going to write that down here. 2x squared plus 3x minus 9 over x squared plus 3. We're going to set that equal to what? 2. Okay, because we're substituting in 2 in for y because that's the asymptote, right? So then I'm going to multiply both sides by this. I will go ahead and distribute as I do that. So this will give me 2x squared plus 3x minus 9 equals 2x squared plus 6. Then I start to simplify, so I can subtract 2x squared from both sides. No, I mean plus 6. Why did you? I don't know. Then I'm going to solve this little two-step equation, so I'm going to add 9 to both sides. So this gives me 3x equals 15, so x equals 5. So my x value is 5. What's my y value? 2. How many times is my function going to cross the asymptote? Once, because I only got one answer here. So now I go to 5, 2, 1, 2, 3, 4, 5, 2, and this is where we're going to cross. Yes. Okay, so now we've got to go back and figure out how to get this graph on here. From negative infinity to negative 3, it is positive the entire time. But in order for me to hit this point here, I'm going to have to be underneath the asymptote. And I don't get to cross it anywhere over here. So that means it lives underneath the asymptote the entire time. Okay, and I'm not going to do what I did last period because I drew it in pieces, but then it was like choppy and didn't look curvy. So we'll talk about it, and then I'll go back in and try and get my curve because I can't erase. If you got a pencil, you can try and do it in pieces. But I'm going to come, so it's going to stay underneath here. It's going to hit this point. Then it's going to come down, and it's going to have to, between negative 3 and 3 halves, I keep writing on it by accident. It's going to be negative, so that makes sense. Then I get this from 3 halves to infinity, it's positive. So it's going to go positive. It is going to cross over the asymptote here, but remember, it doesn't cross over and keep going to infinity like this. It crosses over, and this is my end behavior with my asymptote. It's going to have to come back down and hug the asymptote from the top. So it'll look like this. I probably won't do that much better by doing it all at once, but maybe. It should look something like that, which is not a problem.
Kind of is.
Okay, it kind of is, but it's not. Yeah, no. It's more of a W shape or something. I don't know. Sure, that's a U shape, whatever you want. And this, yeah, that's kind of straight. It really should be a little bit curvier, but I'm not judging your graphs as long as just make sure nothing's pointy because it's always curvy, just like polynomials were, and we do the best we can. But I wanted you to see one where you don't have any vertical asymptotes because most of the time I say most, I mean, not really, but most of what we've seen, we have vertical asymptotes. We do not on here. And remember that the end behavior, that means way out there at positive infinity, we are approaching 2, but we're approaching from above, not from below. Because I don't get to cross it again because I only cross once. And we know that for sure from this right here. Okay, we good? Well, that's what we did here. When you do this, if it crosses multiple times, you will get multiple answers. Just like the first one we did. Yes, exactly. Exactly. So if right here we had a linear that we solved, so we get 1. If it was a quadratic we were solving, we'd have 2. If it's a cubic, it'd be 3. You could have an infinite amount, and we'll look at some of those. Yes, exactly. That's a very good question. So listen, right here we got x equals 5. He said if we'd have just gotten like 3 equals 15, what does that mean? It doesn't cross. If it doesn't make any sense, then that's like your no solution, so they don't intersect at all. And that's definitely a possible type of answer as well. Okay? That's a good question. What else you got? Good. Maybe because it's like the 3rd day in a row I've explained it. That's why we keep going over it. Oh, that's true.